Welcome, Mindsetters, to another exciting lesson for grade 11 mathematics. I have the beautiful Natasha here with me. She'll be taking us through the lesson today. So, Natasha, what are we going to be doing today?
Today we're going to continue with functions, which we started last week, grade 11s. Last week we looked at the parabola. Today we're going to look at exponential graphs and hyperbola.
Awesome. So, guys, you know the drill. To the Facebook page. Hit me up on www.facebook.com/learnextra. And if Twitter's your thing, make sure you hit me up at learnextra. And guys, I'm still giving away this labeler. And I've got a calculator to give away. So get those posts in, write up what you guys are thinking. Let me know if you guys are lost anywhere, if you need help. Guys, that's why the page is there. And guys, I just want to send a quick shout out to Liberty. Thank you for sponsoring. And yeah, we'll see you after this break. And welcome back, Mindsetters, to this another exciting lesson. Today we've got Natasha in taking you guys. So guys, make sure you know the drill. Get to the page, chat to me if you're lost anywhere, if you need help. Let me know so I can get those questions, Natasha. Natasha, take it away.
Thanks so much, Ty. Guys, great to be back, and nice seeing Jacques back after a long time. I hope that you guys in grade 10 enjoyed Jacques' lesson. Today, grade 11s, we're going to be looking at the hyperbola and the exponential graphs. Now, you would remember that you've done hyperbola in grade 10, but you did a very basic type of hyperbola where all you had was y is equal to just the a over the x. There was no p's or q's or anything like you see in the defining equation that I have now. And in that case, the hyperbola was actually, the x and y axis was actually the asymptote to the hyperbola graph. But now we're introducing something new, where the defining equation is y is equal to a over x plus p plus q. And because we've got this introduction of these two new variables, x plus p and then plus q on the other side, what you'll see happening is that you get two different asymptotes. And remember, an asymptote is just a line along of which the actual graph, the hyperbola, our function, does not touch any points on that line. So every point along the asymptote, the hyperbola will not touch it. It is undefined at any point along an asymptote, because often pupils will ask, what is an asymptote? That's what it is. The graph is undefined at that point. So the two new asymptotes that you will be looking at is the one where the denominator x plus p is equal to 0. So if we set x plus p, whoopsie, let's just undo that little mess. So let's try that again. So if I've got x plus p, which is the denominator, and I make that equal to 0, then x is equal to minus p. That will give you your vertical asymptote of the hyperbola. And if you say y is equal to q, which is just from your defining equation, q would obviously be some constant. It would have some constant value. That would be the horizontal asymptote of the hyperbola. All right, now before we go into steps to sketching a hyperbola, just to remind you of the two types of shapes you're looking at. And remember, the shape of a hyperbola is always determined by the value of a. Okay, so a tells you the shape of the graph. And the different shapes we're looking at, you can either have, when a is positive, you have a shape that looks like that, all right? And if a is negative, so that's when a is greater than 0. But if a is positive, you then have something that, sorry, that's when a is positive, but if a is negative, you have a graph that looks like that. All right, so those are the different types of shapes you're looking at when it comes to your hyperbola, all right? Remember the usual case that you did last year, the x and the y-axis were your asymptotes. Now our asymptotes, when I say to sketch a hyperbola, write on the asymptotes, that's the point at which x is equal to minus p or y is equal to q. And I'm going to keep on saying it and saying it and saying it so that it gets drilled into your heads. Okay, you need to remember that. And then one of the very important things in all graphs is to determine the x and y intercepts. As you've done them before, to find the x-intercept, you say let y equal 0. All right, let's try that again. Let y equal to 0, and that will give us the x-intercept. And then to find the y-intercept, we say let x equal to 0. So those steps are exactly the same for your x and your y-intercepts. All right, so let's go over it again. Things you need to remember when you sketch a hyperbola. We need to work out the shape. Remember that if a is positive, you're looking at a graph like I've sketched up here. You're looking at some sort of shape like the first one. If a is in negative, then you're looking at that kind of graph. All right? So first thing you do is you look at a. That will determine which one of these you're going to use. You then have to write down the asymptotes. Once again, that's given by x is equal to minus p and y is equal to q. And lastly, you determine the x and the y-intercepts. All right, so guys, that's really the theory. And when it comes to functions and when it comes to graphs in general, there's very, very little theory. It's all a whole lot of application. So the only way to get better at the hyperbola is to just sketch as many as possible. So that's what we're going to do now. We're going to look at an example of sketching a hyperbola. So the one I've got here, we've got sketch the graph f of x is equal to 2 over x minus 2 plus 1. All right, so from the pointers that I've given you already, the first thing you should do is look at the value of a. We see that it's positive 2, so straight away we know that the shape that we're looking at is going to be a positive shape. We don't know yet what the asymptotes are, but that's the shape that we are looking at. All right, then we have to find the asymptotes. Now remember, we've got f of x, or y, is equal to 2 over x minus 2 plus 1. So our first asymptote we're going to get by saying let x minus 2 equal to 0. So if we do that, we're going to get x is equal to 2. That's one of your asymptotes. Then to get the other asymptote, we say y is equal to q. So therefore, y is equal to 1 will be the other asymptote. So what have we determined so far? We know that the positive a value tells me that I'm looking at a graph that's going to have this shape. I know that the x asymptote is going to be 2, and I know that the y asymptote is going to be 1. So the vertical asymptote is at 2, and your horizontal asymptote is at 1. Remember, we still have to work out the x and the y intercept, so let's do that. All right. So to find the x-intercept, we say let y equal to 0. So we're taking that function that they gave us, which is 2 over x minus 2 plus 1, and we're saying let that, so it's 2 over x minus 2 plus 1, and we're saying the y value there is equal to 0. Let's solve this equation. We're going to get 2 times 3 by your denominator. All right, and when you simplify this, you're just going to get 2 minus 2, which is 0. So x is equal to 0 is your x-intercept. All right, we've got the x-intercept. We now need the y-intercept. So we say let x equal to 0. So if we do that, we're going to get 2 over, remember we're replacing the x with the 0, so it's going to be 0 minus 2 plus 1, and that's going to give us 2 over minus 2, which is minus 1. Minus 1 plus 1 is going to give us 0. So what have we determined so far? We've got the x-intercept is 0. The y-intercept is 0. We've worked out that the asymptote at y is equal, there's an asymptote at y is equal to 1, and there's an asymptote at x is equal to 2. We also know what the shape is. So we've got a, we've got the asymptotes, we've got the intercepts, and hopefully you can all see that you're now ready to sketch your graph. All right. So let's put everything onto our axis. Okay, so we start by, let's just draw our axis up quickly. All right. Remember our shape, keep that in the back of your mind. We know that we have an asymptote at And I'm going to just use a different color. I'm going to use the green to show us the asymptote. So we've got an asymptote, just to remind you. Let's go back up here. An asymptote at y is equal to 1. We've already worked that out. And at x is equal to 2. So let's put that down. So on 2 on the x-axis. Now remember, guys, I'm obviously not drawing to scale. I haven't drawn this accurately, but in your exam you'll have graph paper, and so you'll be able to do it properly. So at x is equal to 2, we're going to draw a line going straight through the point x is equal to 2. And then the other one we worked out was y is equal to 1. So we're going to draw that horizontal line. Okay, and now just remember the shape you had. You were looking at a positive hyperbola, so we know that the shape is going to go into the first quadrant and into the third quadrant. But we also need our intercepts to guide us. And remember that we got our x-intercepts and our y-intercepts were both naught. So let's have a look at what we're going to draw here. Okay, let's use the white, and hopefully you'll all be able to see this. We've got an intercept of x and y is both naught, all right? And remember the shape. We've already seen it before, but remember this is the kind of graphs you're looking at. So that's the shape that we've got to use when we're drawing this graph. So my graph is going to cut through naught, naught, and it's not, very, very important, it's not going to touch the asymptotes. It's going to go parallel to the asymptotes and not ever touch them. Okay, so that's the first one there, cutting through the intercept of naught, naught, not really touching that asymptote of y is equal to 1. Then you're going to have the other part, which we're going to put into this first quadrant here. All right, and then once again, you have a graph that doesn't touch the y asymptote or the x asymptote. It just sort of goes parallel to the two lines. If you wanted to, and sometimes we can ask you to show a point on the graph. Okay, so you've drawn your graph now. Obviously, when you guys do it, you're going to be very, very strict to the rules, and you're going to label your axes and all of that. You're not going to do it as roughly as I did it. So you're going to label your axes, label your points and all of that. And sometimes we ask you to show a point on the graph. So if we do that, so remember here, our equation was y is equal to 2 over x minus 2 plus 1. If I wanted to show a point on the graph, and if you were paying attention during Jacques' lesson on functions, you will know how to find a function value. All you've got to do is put an input into the x value and see what you get out for the y value. So if I say, let's say x is equal to 3, and I want to see what points I'm going to get on this graph, all I do is substitute the x is equal to 3 in place of 3. So I'm going to get y is equal to 2 over 3 minus 2 plus 1. So that's going to give me 2 over 1, which is just 2, and then 2 plus 1 is 3. So therefore my output value, or my y value here, would be 3. So therefore we've got a point, x is 3 and y is 3, that we can plot somewhere on the graph if we had asked you guys to show another point on the graph. So that's important really to remember all of that work you did on functions in grade 10, because it can help you to show points in that on the graph if you are asked to sketch it. Okay guys, so remember, just quickly going over it again, because I am going to give you an example to do at home as well. We need to work out the shape of the graph, we need the asymptotes, and we need the intercepts. So please remember those points when you are sketching your hyperbola. All right, and I think that's time now for us to go back to Ty and take a break.
Yes, definitely. So guys, you heard Natasha. Guys, I hope you guys are doing the right thing, making notes, writing this down, because this stuff is important. It's going to come up in your exams. And guys, remember, again, I still have this stuff to give away. So make sure you keep posting on the page. We are still looking for the best post. But for now, guys, we're going to take a little break, and we'll see you afterwards. And welcome back, Mindsetters, to another session for grade 11 mathematics. Guys, I hope you've had a little nice break. You've gotten your juice. You're ready. You're glued to the screen because there's going to be another intensive session. So guys, make sure you're paying attention. You got your notes and your pads out. And guys, again, if you're lost anywhere, if we cover something that you didn't quite get, make sure you post it on the page so we can go back to it so we can answer it for you. And remember, guys, I can't help you if you don't help yourself and send those questions to the page. Natasha, you can take it away.
Okay, great. Guys, so we've just covered the basics of hyperbolas and how you sketch them, hyperbole, if we're using the plural. So we've just covered the basics, and I'd like you to try this one at home, and I know Ty is going to put it on to our Facebook page as well. I want you to sketch this one. Everyone's been asking for a challenge question, so here it is. Sketch the graph of g of x is equal to minus 3 over x plus 2 plus 3. Remember, the first thing you do, I'm going to give you a clue, is you look at the sign of the a, and since it's negative, it tells you straight away that the graphs you're going to be looking at, they are going to have this type of shape. Okay, so we're going to have one going there, one going on that side. All right, so let me just redraw that. That looks a bit weird from where I'm standing. Okay, so if you have your axes, we're looking at a negative a value, so you're going to have a graph going there in the second and there in the fourth. But obviously not just on your x and your y axes, you need to determine your asymptotes, key point when sketching that graph. All right, so Ty is going to get this up there for you. G of x is equal to minus 3 over x plus 2 plus 3. And what I'd like you to do when you answer this on the page is do it in steps. You know, say the asymptotes are this and that, the x-intercept is this, the y-intercept is that. It also makes it easier when we are checking your answers if you've written it in steps, so I can tell you exactly if you've got it wrong, where you've gotten it wrong. All right, but we'll come back to that later on and give you the answer to that. For now, we're going to move on to exponential graphs. Okay. This one, you've got to be careful, and a lot of students get confused because it has a similar shape to a hyperbola, but it's nothing like a hyperbola. It's a completely different monster. It's something that does completely a different job from the hyperbola. Okay, so don't get it confused with the hyperbola. Your defining equation for your exponential graph is y is equal to b, where b is any number, times a to the power of x plus p plus q. All right. The thing with the exponential graph is, yes, it has an asymptote, but it only has one asymptote. And that asymptote is at the point y is equal to q. So your asymptote, y is equal to q. All right, another important thing to remember about an exponential graph is that it can either be increasing or decreasing. Now, what determines whether the exponential graph is increasing or decreasing? Okay, if you're really fast, maybe you can type up the answer and tell Ty on the page before I get to it, but I'm going to be really quick here. Your graph will be increasing if the value of a, remember a being the base of the exponent, if a is greater than 1. So we're looking at some number greater than 1, then you will get an increasing exponential graph. So you're going to get one that goes like that. Okay, so if a is greater than 1, you get an increasing exponential graph. And if a is a fraction, so if a is somewhere between 1 and 0, and guys, I don't know if you know this yet, some of you might know this, but all of your fractional numbers lie between 0 and 1. So if a is some sort of fraction, like a half, a third, a quarter, and so on, you're going to get a decreasing exponential graph. So to draw that, there we go. Okay, we have a decreasing graph. It makes more sense when it's on the axis, but really when we're talking about increasing or decreasing, we're talking about the y values. So when a is greater than 1, an increasing graph means your y values are getting bigger. And when a is a fraction, it means that your y values are getting smaller. Okay, and we always look at it from the left going towards the right. Okay, and we've already touched on your asymptote is at y is equal to q. And the best thing to do with these, as always, functions, the only way to learn them is just to practice, practice, practice. Okay, and they can get quite complicated, but because we're just looking at sketching, we can't do the really complicated stuff yet because you haven't got there yet with the series. You do all sorts of different graphs combined together and that kind of thing. So it can get really complicated, but you need to know your basics in order to do the complicated stuff. Okay. So the graph we've got here is y is equal to 2 to the power of x plus 1 plus 1. You can use your calculator to work out the points on the graph. Now what I'm going to do is I'm going to show you how to sketch the graph, and I'm not going to use a calculator. Later on, when we come back after the break, after we've done this, I'll show you how to use the calculator to get points on this graph. Okay, so if you really want to know how to use the calculator, you're going to have to come back after our next break. Okay, but for now, let's look at y is equal to 2 to the power of x plus 1 plus 1. Okay, first thing you should do, look at the value of a. The value is 2. That means that you're going to get an increasing graph. Okay, so we already know the shape of the graph. It's going to be increasing. Okay, next step, our asymptote. Remember, your asymptote is the line on the graph at which the graph itself is undefined. It does not pass through that point. And our asymptote here is just y is equal to q, or y, in this case, will have a value of 1. We've got an asymptote at y is equal to 1. So bear in mind the shape of that graph, because that's all we're going to use to sketch it. Okay? The other thing, like we did before in the hyperbola, we need the x and y intercepts. So I know the shape, I know the asymptote, I need the intercepts. Okay, so let's have a look at that. For the x-intercept, we say let y equal to 0. So if I do that, I'm going to get 2 to the power of x plus 1 plus 1 is equal to 0, because remember, all I've done is I've made the y value 0. And I'm just going to try and solve this. And what will happen, guys, if you do this? You'll see you'll get an equation like that. 2 to the power of x plus 1 is equal to minus 1. Now, and this is why I think exponents is one of the most important sections. This you would need to know your exponential equations for, okay? Because you would have already learned in exponential equations that if your exponent is unknown, in order to solve this equation, we need the bases to be the same. So I need a 2 on both sides. But there's absolutely no way that we can change this minus 1 into a 2. It's not possible. So therefore, there's going to be no solution there. So therefore, there are no x-intercepts. Now, if you've lost me there, I suspect it's because you cannot remember your exponential equations. Okay, so you need to go back, revise, 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 practice, 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 go over your exponential equations. Exponents are so important because they come up through so many different sections, and not only in grade 11, also in grade 12. Okay, so if we try to solve this equation, we see that we get no x-intercept. Okay, let's look at the y-intercept. So here we're going to say, to find the y-intercept, we let x equal to 0. Okay, so I'm going to get 2 to the power of 0 plus 1, and that's going to give me 2 plus 1, which is just 3. Remember, 2 to the power of 1 is 2. 2 plus the other one is going to give me 3. So therefore, my y-intercept is 3. And we had no x-intercept. So let's go over it again. We know what the shape is. It's an increasing graph. Okay? Increasing graph with an asymptote at y is equal to 1. We know that it has no x-intercept. And we know that the y-intercept is 3. So therefore, we now have all the points that we need in order to sketch the graph. So let's do that. Okay, we're going to get our axis up once again. Okay, and remember, guys, when you do this, please label your x and your y axes. The first thing I'm going to do is I'm going to put down my asymptote, which I'm going to use, let's use this thick green broken line. Remember that your asymptote was at y is equal to 1. It's one of the first things we worked out. So at y is equal to 1 on the y-axis, we're just going to go straight through like that. Okay, and I'm going to just label that for you so that you can all see that clearly. That's the point 1. And at that point, the graph is undefined. So therefore, if you look at that, that's just your asymptote at the point y is equal to 1. It's your horizontal asymptote, and your graph will not pass through this at all. Okay? We know that our y-intercept is 0 and 3. So at the point 3 on the y-axis, I'm going to put a little dot. And remember your shape. We've got an increasing graph. So we've got a graph that's going to go upwards with all the y values increasing. And it's not going to touch the y asymptote. So therefore, you're going to get a graph that looks as follows. Okay, it's going to go straight through the y-intercept and then just run parallel to the asymptote. So what you'll see is it's going parallel to this asymptote. It's never ever going to touch. It's never going to meet that asymptote. All right, so and that is your graph of y is equal to 2 to the power of x plus 1 plus 1. Okay, some important points again. If a is greater than 1, you have an increasing function as we have here. All right, remember that y is equal to q is your asymptote always. It doesn't matter what the value of a is. If a is some fractional number between 0 and 1, then you have a decreasing graph. All right? And then remember, you need to always work out your x and y intercepts in order to put that on your graph if it's relevant. Sometimes you don't get an x-intercept or a y-intercept. And you can use your calculator to work out these points. So what I'm going to do is I'm quickly going to check with Ty. And if we've got time, I'll show you how to use your calculator to get the points. Or maybe he wants to take a break. How's it going, Ty?
I think we'll take one more Facebook question, if that's okay with you, Natasha.
Okay. Does it relate to the question
Yes.
we're doing? Okay, yes.
Okay. Well, actually, no. In fact, it is one of the questions which is more similar. It's about equation of the graph, trying to find the equation of the graph. Because basically what Motaung asked is that if you're given a point 3 and 1, and then the asymptote is minus 1 and 2, how can we get the equation of the graph?
Okay. All right, guys, this is what I was saying before. It all gets very complicated. I cannot go into that because that's a completely different section. Finding the equation of any graph, it's completely different, and we will be covering it in later sections in the live show. Unfortunately, if I were to go through it today, it's going to involve a whole big explanation, and some of you that haven't done it at school are going to get terribly lost. So all I can say to her or him is to just stay tuned. We will get there, but we're just not going to have time to get there today.
Yeah,
all right.
I think so. But for now, I think we'll just take a break instead then.
Okay.
Right.
Or we can do the calculator table work.
Well, we can do that. Yeah, definitely.
I think so. Okay, guys, what we're going to do is before we take a break, as I was just saying to Ty, it might be worthwhile to show you how you can sketch points on your exponential graph using your calculator. And I know that all of you get really excited when it's calculator time because you often think, well, it's less work, but it really isn't. Okay, just with the table, it makes life a little bit easier because we can sketch this graph just plotting a table of values, or we can use the calculator. So I'm going to show you how to use your calculator. And I'm going to do all the steps on the calculator, so you're going to need to follow the steps on the calculator. All right, remember the equation we were dealing with here, and this is the one we're going to be using, is y is equal to 2 to the power of x plus 1 plus 1. That's the equation we're dealing with. And that's the one I'm going to punch into the calculator. So first step, call up your calculator. Okay, and hopefully you can all see this calculator nice and big. All right. Now what I've done to get f of x is equal to, all I do is on the calculator I go mode, I hit the mode button, and I pressed 3 because I want a table. Okay, so you go, that will come up with f of x is equal to something. Now we want to write in 2 to the power of x plus 1 plus 1. So let's try this. Okay, hopefully it all works really nicely. So I've got 2, and I want a power button. There we go. And I want to write in x. So I'm going to go alpha x, and we want plus 1. So I'm going to press plus 1. And then we're done with the exponent bit. So now we've got to come back down to the ground or to the floor of it. And let's see if that's going to work. All right, there we've got it, and we're going to say plus 1. Okay, so if you look at that, f of x is equal to 2 to the power of x plus 1 plus 1. That's exactly the equation we've been asked to sketch. Now what we do is you hit the equals button. When you do that, it says start. Now you want to start, because remember you're setting up a table, you want to start with values that are negative and you want to end with positive values. So we're going to go from minus 1. Okay, and we're going to go, you can go up to 5, you can go up to whatever number you want to, but just for the sake of ease, I'm going to go up to positive 1. And they say steps. Now what the steps tell you is the little increments that you're going to go up in. So it's going to go 1, minus 1, and then 0, and then 1. So it's going to go up in levels of 1. That's all the steps tell you. So I'm going to say in steps of 1, and it gives you this table. All right, so if you look at your calculator, you can see the input values. X is minus 1, 0, and 1. Minus 1, 0, and 1. And then on the other side, the f of x gives you the y values. So when x is minus 1, y is 2. When x is 0, y is 3. That should ring a bell, guys, because remember, we worked out the y-intercept. So when x was 0, we got that, y is equal to 3. So that one should really ring a bell with you. We've already worked that out. And when x is 1, y is 5. How does it help you? Remember, sometimes we say show points on the graphs and that kind of thing, or tell if a point lies on the graph. You can do that by using this table. So if I wanted to, on my graph now, when x is minus 1, y is 2, I could just go to the graph where x is minus 1, y is 2, and put a dot there and say that's the point minus 1, 2. Okay, that's how it helps you. The point 0 and 3 was given, and I think the other one was 3 and 5. We could also put a 1 and 5. We can also put that point in. Okay, so the table really just helps you to plot points and to sketch your graph, especially if they ask you to show another point. It's useful. All right, so Ty, I think this is a good place to take a break.
All right, awesome. So guys, I hope you're paying attention, because that was complicated. I enjoyed it. Complicated, but I enjoyed it. So guys, you know the drill. Go grab something to snack on. Go grab some water. Make sure you're focused for the next session. But for now, we're going to take a little break, and we'll see you afterwards. Welcome back, grade 11s, to another exciting lesson. Guys, I hope you're paying attention. Got your notepads and you're writing the stuff down. Seeing a lot of you guys answering that challenge question. Awesome, awesome, awesome stuff, guys. Keep going, keep going, keep going. Right now, I'm actually going to hand over to Natasha.
Okay, great. And I've had a look at the Facebook page, and some of you guys are doing really well. The challenge question that we put up, which was that one there that's on the board, a lot of you are getting it right. So well done. Okay, and a lot of you are on the right track already to sketch the graph. So I'm going to go ahead and answer this challenge question for you, for those of you who don't quite get it yet. Okay, so first thing we do, we look at the minus 3. Remember that told us the shape that we were looking at. So we're going to have a graph that looks kind of like that with two separate pieces. All right, the negative tells us that's what the shape of the graph is going to be. The next thing we had to do, and I saw a lot of you got this right, so well done, was to work out the the asymptotes on the x-axis and the asymptote on the y-axis. So let's have a look at that. So remember to find the asymptote on the x-axis. I say x plus 2 is equal to 0, and I get x is equal to minus 2. Incidentally, guys, I just remembered some of you might be getting a bit confused because we were dealing with exponential graphs. Now we've gone back to the hyperbola, which was the challenge question that I gave you. All right, so now we've gone back to the hyperbola. This is not exponential graphs anymore. All right, so x is equal to minus 2. That's our asymptote on the x-axis. And then y is equal to 3. That's the asymptote on the y-axis. So that's our horizontal asymptote, and x equals minus 2. That's the vertical asymptote. Next thing we need to do is to find out if there's any x and y intercepts. So we do that as we always do in any graph. To find x-intercept, you let y be 0. All right, so x-intercept, we're going to get y is equal to 0. So therefore, I'm going to have minus 3 over x plus 2 plus 3 is equal to 0. And we're just going to solve that equation. It's just a linear equation. So I times through, I'm going to get minus 3 plus 3 times x plus 2 is equal to 0. So minus 3 plus 3x, just timesing the 3 into the bracket, plus 6. And we get 3x is equal to 6 minus 3 on the left-hand side is just going to give me 3. So if I take it over to the right, I get minus 3. And therefore, x is equal to minus 1. So for all of you guys who got your x-intercept, well done. And I saw on the page some of you got this. X is equal to minus 1. That is our x-intercept. We now need to find the y-intercept. So we let x be 0. Okay, so y-intercept, we're going to let x be 0. So we're going to get minus 3 over 0 plus 2. And let's just go back up here. It was plus 3. All right, and that's y is equal to. I'm going to get minus 3 over 2, which is just minus 1.5 for those of you who prefer changing them to decimals. It's minus 1,5 plus 3, and minus 1.5 plus 3 is just going to give me 1.5, or 1,5 if you prefer to plot things in terms of decimals. Okay, so we've got a y-intercept at 1.5, x is equal to minus 1. We have an asymptote at x is equal to minus 2, and an asymptote at y is equal to 3. So if you've got all of this so far, you're really in the position now to sketch your graph. So let's have a look at what this graph's going to look like. All right, so I'm going to put the axis in. All right, and the first thing I'm going to do is put in my asymptotes, and I'll use a different color here. Let's just use the green. We've got an asymptote at y is equal to 3. So that's somewhere there. And then we've got an asymptote at x is equal to minus 2. So that's somewhere there. All right, remember the shape of the graph we've already seen before. It's going to look like that. That's the shape that we're looking at. Okay? So now we're ready to plot all the other information we have on the graph. Okay, let's just remember that's the y-axis, that's the x-axis. This is the line y is equal to 3. This is the line x is equal to minus 2. And now I want to plot down all the other information I have. I know the shape, firstly, is going to have that kind of look in that second quadrant. There we go. And it's not touching. It's not supposed to touch your asymptotes. And then remember, we've worked out that the y-intercept was 1.5. So at 1.5, I'm going to put a little dot. And then the x-intercept was minus 1. All right, and then all we're going to do is we're going to join those dots up and make sure that the graph doesn't hit your asymptotes. If you've made it hit your asymptotes, your teachers sometimes, well, they should actually take off marks. All right, there we go. So it's cutting at minus 1 on the x-axis, 1.5 on the y-axis, and that's our shape. We've got our both our asymptotes, and that's a good question. If you've done this in an exam, you get some really nice marks. But remember, as I said before, this is really the basics. We're just showing you how to sketch the graphs. They get far more involved, especially when we look at graph interpretation. And then, as someone was asking Ty before, where we have to find the equation of the graph. Unfortunately, today's lesson is not about finding the equations of the graph. That would take an hour just by itself. All right, so hopefully all of you that got all the points right you were able to sketch this, and this is what your graph looks like. Do we have any comments yet, Ty?
Well,
about the graph?
Not as yet. Again, I think people are still in the process of actually just writing it in. So far, people are just enjoying the show. A lot of answers to the challenge question. A lot of answers to the challenge question. So that's good. That's good. Making sure that you guys are working out there, We're not just doing this just mahala. You guys must be working out there. And yeah, I think, yeah, that's about it. Yeah.
All right, so should we carry on with my last example, which is back with exponential graphs?
Yeah, I think so.
All right, guys, so that's what we're going to do is I've got a question on exponential graphs. So I gave you one at home to do on the hyperbola, which I've just answered. Now I want you to take this down, and if you can get the points quicker than I can, then send them through on the Facebook page. But here we're looking at this exponential graph. Y is equal to 2 times a half to the power of x plus 1 minus 4. And what you'll notice here is we've done something different, because remember, the first example I showed you, we were looking at a whole number base. Here we've got a fractional base. So hopefully all of you that were listening and you were taking down notes, you know straight away that we're talking about a decreasing exponential graph. So we're going to have one that has that kind of shape. Okay. So that's the kind of graph we're going to end up with. The a half, which is my base, tells me immediately that that's the kind of graph we're looking at. It's a decreasing exponential graph. Okay, so you guys at home, what I'd like you to do, if you can do it really quickly, because we're running through the last few minutes of our show now, send us the y-intercepts, your x-intercepts, and your asymptotes. Okay, so let's see if you get it all right by the time we finish off with this one. So let's start. We know the shape, it's a decreasing graph. Next step, what is the asymptote? Okay, remember for the asymptote, it's just y is equal to q, so therefore in this case y is equal to minus 4. That is our asymptote. It's just one asymptote that you're dealing with, guys, when you look at exponential graphs. All right. We're also going to need to work out the x and the y-intercepts. But what I'm going to do, because I have used this page to do the other example, I'm going to quickly transfer everything over to the next page. All right. So we've got the question we were dealing with is y is equal to 2 times a half to the power of x plus 1 minus 4. And let me just go back and make sure that is right. Y is 2 times a half to the x plus 1 minus 4. All right, good. We've got it all down. Remember, just from the other page, we've got our y asymptote at minus 4. And we know that this is a decreasing graph. That's all we have so far. Okay, now we need to work out the x-intercept. So remember, to work out the x-intercept, we just set y is equal to 0. All right, so I'm going to get 2 times a half to the power of x plus 1 minus 4 is equal to 0. And as I said to you guys before, when we were starting with these exponential graphs, you need to know your exponent work really, really well. So if you've forgotten it, please, please go back and revise, especially exponential equations. All right, so the first thing we're going to do is take the 4 over to the right-hand side. All right, and I'm going to divide both sides by 2. So I get a half to the power of x plus 1 is equal to 2. Okay, now what we need to do, because remember, if we want to solve for the exponent is unknown, I need to have the same bases. And hopefully all of you that remember your exponent work, we realize that I can rewrite 2 as a half to the minus 1. Now why can I do that? Let me just show you. Remember, a half is 2 to the power of negative 1. This is all goes back to exponent works. And I'm raising that to the power of minus 1. So I can rewrite a half as 2 to the minus 1. If I then raise that to minus 1, I'm just going to get 2 to the power of 1. So all I've done here, guys, is I've rewritten 2 as a half to the minus 1. If you don't like that and you prefer to stick with the 2, the other way you could have done this is you could have changed the left-hand side and said a half. Okay, so this is the other way. You could have said a half is 2 to the minus 1 and raised that to the x plus 1, and then your bases are the same on both sides. Okay, so we could have either changed it to the 2 or we could change it to a half. So I've just chosen to change it to a half. So therefore I get x plus 1 is equal to minus 1. And therefore, we get x is equal to minus 2. So we've got minus 2 as our x-intercept, and now we've got to work out the y-intercept. Remember, to work out your y-intercept, you've just got to say x is 0. Okay? So we're going to get y is equal to, just going to write it all out again, a half. Remember, what we're doing here is we're replacing the x with a 0, because I'm trying to work out my y-intercept. So I've replaced x with a 0, and I'm going to get y is equal to 2 times a half minus 4. 2 times a half is 1. 1 minus 4 is minus 3. So therefore, we have a y-intercept of minus 3. Okay. So are we ready to sketch it? And I hope that all of you are saying, yes, we are ready to sketch it, and you have your drawing at home. This is what it's going to look like. Okay, so we put down the axes. Okay, and then we're going to put down our asymptote. Remember, the asymptote is at the value y is equal to minus 4. So that's going to be at the point y is equal to minus 4. Let's just write that in. That is your y-axis, and that is your x-axis. We write down, we label our asymptote. It's very, very important to label, especially in your tests and your exams. We had our x-intercept at minus 2. So on minus 2 on the x-axis, we put a little dot. And then we had the y-intercept at minus 3. All right, so we put a little dot there. Remember, our shape was decreasing, so therefore I'm going to have a graph that goes all the way from the left, and it decreases down but never touches that asymptote, the horizontal asymptote. All right, and that's really what our graph looks like. Okay, so hopefully you guys have got this, and you've answered it on the page, and you sort of know what's going on. This is really, really important. This is the basis of all of the functions that you're going to do when you get to grade 12. You need to remember this stuff, your hyperbola, your exponential graphs, parabolas from last week, straight lines, all of that stuff's going to come up. All right, guys, so I'm quickly going to recap, just remind you how we did this exponential graph, and then we'll finally find out from Ty if any of you are battling. Okay. First thing we did was, remember, we determined that if a was a number greater than 1, we had an increasing function. If a is a fraction between 0 and 1, we had a decreasing function, such as this. We then worked out our asymptote on the y-axis by saying y is equal to q. Then you work out your x and your y-intercepts, and that's it, and you're good to go. All right, so Ty, is there anything that we still need to answer on the page, or are we done?
No, I think we're good to go. Everyone seems to have had fun and loved the questions. But guys, from us today, we had fun. Hope to see you next week. In fact, no, we will see you next week. Make sure you're here, even tomorrow. But for now, peace.